Question 10. A scientist is studying the number of bees and the number of wasps on an island. The number of bees measured in thousands, NB, is modelled by the equation NB is equal to 45 plus 220 e to the 0.05t, where t is the number of years from the start of the study. According to the model, part A, find the number of bees at the start of the study. Well, the start of the study is when the number of years is equal to 0. So when t is equal to 0, we can substitute that into our MB, and so MB is equal to 45 plus 220, e to the 0 is 1. That gives us a number of 265, and this is in thousands. Part B, show that exactly 10 years after the start of the study, the number of bees was increasing at a rate of approximately 18,000 per year. Well, the rate of increase is NB with respect to time. So the rate is the derivative of NB with respect to time, which we need to find first of all. So differentiating, 45 will differentiate to 0. 220 e to the 0.05t, 220 times 0.05 is 11, and then that's still e to the 0.05t. When t is equal to 10, substituting that in, we get that dNB by dt is 11e to the 0.5, which is 18.135 and so on, which is close enough 18,000 a year. So it is approximately 18,000. The number of wasps measured in thousands, NW, is modelled by the equation NW is equal to 10 plus 800 e to the minus 0.05t, where t is the number of years from the start of the study. When little t equals capital T, according to the models, there are an equal number of bees and wasps. So that is when our two models are equal to each other, we have the same number of bees and wasps. So we can put these two equal to each other. We've got our NB, 45 plus 220 e to the 0.05t, and our NW, so our number of wasps, 10 plus 800 e to the minus 0.05t. If we rearrange this, so subtracting the 800 e to the minus 0.05t and subtracting the 10, we can form this equation here. And the reason we're doing this is because we're looking for a quadratic function with e. So let's multiply each term here now by e to the 0.05t. That gives us 220 e to the 0.1t plus 35 e to the 0.05t minus 800 is equal to 0. Now this is a quadratic in terms of e to the 0.05t. Let's just look at what's happening here. It's a little side note. If x were e to the 0.05t, then x squared would be e to the 0.1t. When you multiply indices, we're adding them. So x squared would be e to the 0.1t. And so this could be written as a quadratic 220x squared plus 35x minus 800, where our x is our e to the 0.05t. Using the calculator, we can solve this quadratic to find that e to the 0.05t must equal 1.829 and so on. This is because the second value, which is negative, cannot apply in this case. Taking natural logs of both sides gives 0.05t is equal to ln 1.829 and so on. Dividing by 0.05, we get a value of 12.075 and so on, which to two decimal places is 12.08.